In this video, we're going to get ourselves set up to be able to take any quadratic equation and write it in vertex form. Vertex form of a quadratic equation is when it's of the form g of x equals a times x minus h quantity squared plus k. So vertex form is really helpful for us because it helps us quickly identify what the vertex is, as well as any changes that are made to the shape of the parabola. All right, so here's what we're going to do. We're going to determine the values of a, b, c, d, e, f, g, h, j, and k so that these sentences are all equivalent, so that this equals this, which equals this. You'll notice that sometimes variables repeat. That means that this b here is the same as this b here. So once you figure out b, it works for both. Okay, what we're doing to set up these equations or to make them true is we're actually going to be using completing the square. But when we use completing the square, we're adding an element to the problem. So anytime we add something, I can undo that by subtracting the same amount, right? So if I have q, and then I come along and add 5 to it, because why not? Well, I can't just add 5 to q without any consequences. To undo that plus 5, I would take away 5. So what we're practicing here is adding and subtracting the same amount to maintain what it originally was, which sounds simple, but it's actually a little more complicated than that. Let's take a look. So here, this is what we have, x squared plus 8x. This should also be 8x squared plus 8x, but I want to actually use completing the square here to create the vertex form appearance. So if x squared plus 8x are 2/3 of a perfect square trinomial, the third would be half of this squared, so that would be 4 squared. That tells me a is 16. Woohoo! Got the first one. A is 16. But I can't just go on adding 16s to expressions. That's not how math works. If I add 16, that's not the same as x squared plus 8x. That's x squared plus 8x plus 16. So in order to undo that plus 16, that means that here I need to take away 16, which means b must be negative 16. Now I have to be careful about this, what this is, because if there's a coefficient here, then it's not actually what we added to that side. And so we're going to see an example in a few seconds where that happens. Okay, so now we're good. We know a and b. Now our third step, we have x plus c squared. So this was the perfect square. This was x squared plus 8x plus 16. That was our perfect square trinomial. Now it's the root. So that would be x plus 4 quantity squared, which means c is 4, and then plus negative 16. So here's the vertex form. Normally we would just change that to a minus, but for the sake of this problem, we don't need to worry about that. All right, we're done with A, B, and C. On to D, E, and F. In our next example, we have x squared minus 26x. We want to make sure that that stays the same here and here. We want to make sure that they're all equal to x squared minus 26x. Here we're going to complete the square. So we're going to take the half of that, it's 13. Square it is 169, so D is 169. Now here I just added 169 to an expression. To undo that, I would need to take away 169 or add negative 169. So E is negative 169. Now here, whoops, let's put that square there. Great. Now here we have the root of that perfect square trinomial. So that root would be x minus 13 squared. So now we know that f is 13. And then plus e plus that negative 169. The good news is we don't have to graph this because look at that vertex, 13 comma negative 169, yikes. That would be it for letter B. Letter C is going to be a little more complicated. Why is it more complicated? Because the leading term has a coefficient. We have 2x squared plus 32x. That's what each expression should equal in this equation. So the first thing we have to do is factor out a 2. When we factor out a 2 from these two terms, we're going to be left here with, divided by 2 would be 16x. Notice that normally, so g is 16x. Normally, we would factor out the entire GCF, right? They both have an x as well. But because we are completing the square, we need the x squared and the x left in. So we only factor out the leading coefficient whether it's the GCF or not. When we do completing the square, you need to have a leading coefficient of 1, so you have to factor it out. Okay, so I factored out the 2. Now I have x squared plus 16x. So now I have 2 times x squared plus, this is 16x, plus h. Well, this is double the root, so that would be 8. This would be 64. So h is 64. And here's where it gets complicated. I didn't actually add 64 to this side because the 64 is in parentheses and it's being multiplied by 2. What I actually added to this side is 2 times 64. So I really added 128 to this side, which means to undo the plus 128, I need to take away 128. So that means j is negative 128. So if you have a number out in front, what you actually added to that side is this number times this number. So just be careful with that. Now lastly, we have 2 times x plus k. So this is the root. Do we know the root yet? No, the root is 8. So k is 8. And this would be 2 times x plus 8. Yep, it was positive. Great. Squared. And then we have plus negative 128.